Good morning, everyone. This is your physics class, and we are dealing with ray optics. Well, there was a bit of a gap in the last class and this one. Just let us recollect what we had done in the previous class. In the previous class, we had seen what do you mean by reflection. Whenever light falls on any medium or boundary between two mediums or any surface, it will bounce back into the same medium. This phenomena is known as reflection of light. And we had also seen incident ray, reflected ray, normal, and we had also seen the laws of reflection. All of us remember this, yes or no? The incident ray, the reflected ray, and the what
Yes,
do
sir.
we say? Normal, they lie in the same plane. Now we'll understand simple things about reflection. Remember, we are going to write them probably as points, and I hope that you can remember these points and mark them. Now I think we have discussed this point. I'm just marking it to start. What happens if the angle of incidence, if angle of incidence is 0, the angle of reflection will also be 0, because angle of incidence and angle of reflection are same. Yes or no? Do we understand this?
Yes, sir.
So if the angle of incidence is 0, then the angle of reflection will also be 0. Now, how it looks in different cases, that is what we got to see, and I hope you can see this in terms of the golden points, and we will see those points. See, do you see here what we have here? This is a plane mirror. Do you see this? We will be going into plane mirrors and spherical mirrors just by the end of this class probably. This is a spherical mirror. Do you know what type of mirror is this? The second one? This is the first one, which is a plane mirror. The second one, Abhiram, yes, very correct.
Spherical mirror.
It's a concave mirror, beta. It's a spherical mirror, yeah, but it is concave. And the third one happens to be
Convex.
convex. Plane, concave, convex. These are the three mirrors that we have to deal with. Now, remember, in plane mirror, this is how a normal ray, which has angle of incidence 0, it will fall normally, it will return back or retrace its path. This is how we say it. It retraces its path. Now remember, in physics, the problem is, if you understand a concept, you'll have to apply it in problems. Now in problems, they will not say that angle of incidence is 0. What will be the angle of refraction? The problem will be faced. The problem will be framed in different languages. The problem may be such that where should I place an object so that its image forms at the same place? Now, if the image has to form at the same place, whatever rays are going, the ray has to come back in the same path. We call it retracing the path. Now, rays will only retrace the path when the angle of incidence is 0. Now, you can see in case number 1, the ray is falling normally and it is retracing its path, angle of incidence. This is the incident ray. If I would mark by the green arrow, this green arrow is the incident ray. I hope everyone sees this. Then this blue arrow is the reflected ray. Are we seeing this, the green arrow and the blue arrow? The ray is retracing its path. This is happening because angle of incidence is 0, and therefore the angle of reflection is also 0. In case number 2, also the same thing is happening, but the normal, because this is a spherical mirror, the normal will always pass through the center of this mirror, which is known as the center of curvature. I know you might not know this term, but center of curvature is the center of the mirror. So a ray, and I will mark it as the green ray, a ray which passes through the center of curvature, incident ray, it will fall normally on the mirror. Are you getting me? So this angle would be 90. That means the angle of incidence becomes 0. And as you can see, in this case also, angle of refraction, the blue ray is 0. The ray is going to retrace its path. Do we understand this? Yes or no? Can I have reason that we understand this? So, it might look different in case number 1 and case number 2. Case number 1, it might be easier for you to understand that it is going like this and coming back like this. Case number 2 is also same. It's also falling normally. Angle of incidence is 0 and angle of reflection is also 0. And same thing is happening in case number 3. The green one, which is the incident ray, is again falling normally on the mirror. That means the angle of incidence is 0. And as you can see, the angle of reflection is also 0. The only difference is here the center of curvature, because it is curved like this. The center of curvature is on the other side. We will get to know what is the center of curvature, radius of curvature, all those things we will understand. Right now, what you got to understand is that if the angle of incidence is 0, angle of reflection will be 0, and the ray will retrace its path. I hope we have understood this point, which is point number 2. Point number 1 is very simple. It is known as the rectilinear propagation of light. I hope all of you know what is this rectilinear propagation of light. Light will always travel in a straight line. Light always moves in a straight line. That is known as the rectilinear propagation of light. Third point we have already discussed. Whenever light undergoes reflection, its frequency, wavelength, and the speed does not change. Do we remember this? Can I have some reason that we remember this? When light undergoes reflection, and I hope you will note this down, because any one of these will come as a question in your exam, whether it is NEET or JEE Main or advanced. Frequency, wavelength, and speed does not change, but there is something known as phase difference or phase of the wave, which we will deal when we go into reflection of waves. The phase of the wave may change. So you will add here, but the phase of the wave, or phase of the ray, or phase of light can change. I hope everyone is noting this down and marking them as important points.
Sir.
Yes, beta. Your voice
Sir,
is.
explain it in whiteboard, sir.
Yes, it is on in the whiteboard only, beta.
You are screening the share, sir. Don't screen share.
I'm not screen sharing. Don't worry. It's on the whiteboard only, beta.
In this way, we are not understanding, sir.
What are you not understanding? We have already discussed this. You have to write it only, nothing else. You just need to write it. Okay? I understand this. You just have to write this, draw this diagram and write it. What you have not understood, tell me. What have you not understood here? We have discussed this point. Now, angle of incidence is 0. The angle of reflection will be 0. What is there you have not understood here? Tell me. You have to draw the diagram. If I draw the diagram, it will take time. I'm just saving time so that you can draw it on your on thing. If I draw this diagram, it will take time. I don't want to waste time. Okay. Tell me what you have not understood. Tell me, beta.
Yes, sir.
You've understood?
Sir,
Yes, beta.
stop this online class and come to HYD.
Yes, beta.
Stop this online class and come to Hyderabad, sir. Offline.
Okay, I'm coming there, but have you written these things? 2 points you have to write. You have to draw these 3 diagrams. Can you draw these 3 diagrams, beta?
Sir, due to this online class, we are unable to understand.
Have you drawn these 3 diagrams, beta?
Sir?
Have you drawn the diagrams, beta? You have understood the angle of incidence is 0. That is what you need to understand here. So these are the things that you have to remember. I will write them point wise. Number one, angle of incidence. And I will write it here point wise. Don't worry. I will write here point wise. I just want you to draw the diagram, nothing else. So what you have to understand, I've already written it. If angle of incidence is 0, the
Sir, we
angle,
didn't write, sir.
the angle of reflection is,
Sir, we are still writing.
yes,
Can you
yes,
show?
I'm just writing it on the whiteboard. Angle of incidence is 0, angle of reflection would be 0. Okay, that is the only thing that you have to understand, and you just have to draw the diagram, nothing else. I'm just showing you the diagram so that you can draw it quickly. If I draw it and then you draw it, it will take time. That is the only concern that I have, that I want to do things a bit, save time here. So here you see center of curvature. I understand that you don't know what is center of curvature. We will come to it. Once we are done with plane mirrors, we will go into curved mirrors, and then we will understand this. I just want you to draw neat and clean diagrams, and that is why I'm showing the diagram from this, nothing else. So that the diagrams are neat and clean. Got the point, beta? I just want you to have a clean and neat diagram, and that's it. You understand what is this? And nothing. You don't have to write everything, you just have to draw the diagram, that's it. Draw the diagram? Okay. I'll give you time to draw it. We have written these things in the last class, no? Frequency, wavelength, and speed does not change. We have written this in the last class, yes or no? No, we have not written. Yes, I think are there new students that have joined? Because I think we have written this in the previous class. It was just a recap of the previous class. You don't remember what we had done in the previous class? I talked about reflection. I told you what things remain same, what things are different. I was just giving you a recap of the previous one. Anyways, I thought that we have already discussed this in the previous class. Are you done?
Yes, sir.
Everyone? You have understood angle of incidence is 0, then an angle of reflection would be 0. That's it. And light travels in a straight line. What all things remain same? Frequency, wavelength, and speed. Okay, so I'll just note it down here also. So point number 1 is angle of incidence is 0, angle of reflection is 0. How do we say it? We say that the ray will retrace its path. The ray will retrace its path. It will just come back on the same path as it had gone. Then second thing, on reflection, frequency. I hope I told you frequency is F. Frequency, wavelength, lambda, speed, these three things does not change. But what changes? I've already told you. What can change? What can change? Frequency, wavelength, and speed does not change. What can change? Phase of the wave can.
Yes.
Yes, phase of the wave can change. Now, what do you mean by this phase of the wave? Don't worry. When we deal into wave optics, we will be dealing with this phase and then we will discuss this. Okay, point number three, important point number three that you have to remember is V is equal to F lambda. Do we all remember this point?
Yes, sir.
V is equal to F lambda. So that is what you will write. V is equal to F lambda. V stands for the speed of light. V stands for the speed of light. It could be speed of light. This could be speed of any wave. Doesn't matter. V stands for the speed of light or the speed of wave. What does F stand for?
Frequency.
Great. What does lambda stand for?
Wavelength.
V is equal to F lambda. This is what you should remember. You should also remember point number 4. Light is the EM wave, electromagnetic wave. I hope you know this. Yes or no? Light is an electromagnetic wave. And what is the speed of light? We normally call it speed of light as c. And the value of c is 3 into 10 raised to the power 8 meter per second. This is the fastest speed of light and it happens in vacuum. The simple things about light that you must remember. Simple things that you have known, and that is how you are going to remember them. Now, what we are going to do, we'll have to understand reflection. We'll have to understand how reflection happens from a plane mirror, how it happens from a curved mirror, and how we are going to do it. We are going to study them under various different heads. So the first thing would be plane mirror, because that is the easiest one to understand. I think you have also read about plane mirror previously in your 10th standard, I guess. Did you study about plane mirrors in your 10th standard? Yes or no? Yes, no? Yes.
sir.
Yes. Okay, we understood that. So we will start with the next heading, and the next heading is plane mirrors. Next heading is plane mirrors. Now, what do you mean by a plane mirror? Everyone understands that? The surface is absolutely flat. When I say something is a mirror, what we understand is it is going to reflect everything back. It is not going to absorb anything. It is not going to transmit anything. It is going to reflect everything back. That is a plane mirror. And how do we make a plane mirror? We make it at a straight line and then we put hashes like this. This hashes, what does it stand for? It stands for the painted surface or blackened surface so that nothing goes on the other side. This is the painted or the blacked out surface, so nothing goes on the other side. And this is the reflecting or the polished surface. Yes, beta? Anything troubling you, beta? Yes? What happened? Can't see the whiteboard? You can't see the whiteboard, beta?
Yes, sir.
Everything okay?
Okay, sir.
Okay. So I have the painted surface, nothing will go on the other side. And once we have the polish or the flat surface or the reflecting surface from which rays are going to get reflected back. Now, before we go into any type of mirror, whether it's a plane mirror or it's a curved mirror or a spherical mirror, we will have to understand some basic terms Now remember, this entire chapter, optics, is about understanding those terms. It's about understanding those terms. There will be a lot of definitions. There will be a lot of formulae, and everything depends on understanding of that particular term. If you can understand those terms very simply in the very beginning, you would be able to get this chapter very easily. So please pay attention on to the various definitions or terms that we are going to do. And the first term is object. We are going to hear this term object every now and then because it's all about object. Now, what is an object? We are dealing in optics, ray optics. What do you think is an object in an object optics? And you would have known this from your previous knowledge. What is an object? Yes, tell me. What is an object? What do you mean? What do you understand by an object? Now, what happens, beta? Things which we use or which we are very frequently using here and there. You might sound very simple, but if someone asks you what is the definition,
Study of light.
object is the study of light. Object study of light. I don't think it makes sense. Object is the study of light. No, I don't think it makes sense. Optics is the study of light. Yes. But
Source
what?
of light.
Yes, beta. Source of light. Okay. Not very incorrect. It's maybe you might have heard somewhere that an object is something that is a source of light. Yes, to a great extent, this definition is correct. But right now, we want to understand it in a way in which we are going to use it in questions that we are going to solve. So, in any question that is there now, let us say, for example, me, am I emitting light? I might be emitting light, but that light that I am emitting, that radiation I might be emitting, may not be visible to your eyes because I might be emitting ultraviolet or infrared radiation. You might not see it. So I might not be a source of light. The sun is a source of light. Yes, sun is a source of light. But every time when we are thinking of an object, we are not thinking about sun or we are not thinking about that LEDs that are growing on there. We're probably thinking of something like this, which is an object. Now, this does not actually emit any source of light. It's not a source of light. It does not emit light. So that may not be a very good definition for an object. But yeah, to some extent, correct. Object is something that emits light, but it's not very relevant here. Can you think about something else? You think about something else, what might be an object? Now, I'll give you a definition of an object, and probably then you can make out the definition of an image. Now, the first thing that we talked about in this chapter, reflection, was incident rays and reflected rays. Do you remember? I draw a ray which was incident ray. In the diagram, I draw it by green color. Then I drew it in terms, then I drew the reflected ray. Object is defined by the incident rays. Object is defined by incident rays. And what is an object? It is the point of intersection. Now, can you complete this sentence? This is the point of intersection. Can you complete this statement? An object is the point of intersection of which one? If you can complete this statement, that means you are able to picture what an object is going to do. And that is what you have to understand. If you can picture what an object is going to do, you will be able to solve questions based on that object. What is an object? An object is a point of intersection of point of intersection of
Incident ray and reflected ray.
it cannot be point of intersection of both. Just cannot be the point of intersection of both. It has to be the point of intersection of something similar. So it cannot be both incident ray and reflected ray. Then what?
So point of intersection of incident rays.
That is absolutely correct. This is the point of intersection of incident rays. That means it may be the point from where incident rays are coming, or it may be the point from where incident rays are appearing to be coming. So now we have removed this ambiguity that it has to be a source of light. It may not be a source of light. It is something that is probably emitting incident rays from where incident rays are coming, and where these incident rays meet, point of intersection. Point of intersection. Where the incident ray meet, that is your object. Do we understand this? Can I have some raise hands from everyone that we have understood this? One class does not have camera, so I don't get it. I hope, yes, online students are also getting me. Boys in this class, are you getting me better?
Yes, sir.
Everyone? Point of intersection of incident rays is known as the object. Now you might have heard the different types of object. I hope you have written this. Yes or no? It's a simple line, nothing else. I won't make you write anything extra that is required. And whenever I require to show you a diagram, and if I want to show you a clear diagram, I probably show you a picture. Okay, it is a point of intersection of incident rays. Now you might have heard that this object can be of two types. Can you tell me what are the two types of object that we are going to deal with? Yes? Anyone? You might have heard about this. Don't worry. There's nothing new here. We are just wearing the same jeans, but we are just changing the label of that. What are the two types of object that you might have heard? Probably you have not heard about the two types of object, but you have definitely heard about two types of images. Yes or no?
Real and virtual object.
Yes, that is correct. You have heard about two types of images, real and virtual. That means there are also two types of objects, real and virtual. Real and virtual. These are the two types of objects. You say real object, I can understand object is real. What do you mean by a virtual object? The object does not exist. Now again, the pattern passes on to you to make me understand what would be a real object and what would be a virtual object. And remember how we have defined the object. An object is the point of intersection of incident rays. Now, what would be a real object? What would be a virtual object? That is the point. And I wait for your answers. What would be a real object? What would be a virtual object? Think. What would be a real object? What would be a virtual object? Anyone with any idea?
The object which is in front of reflected side of mirror.
Great. That is absolutely correct. The object which is on the reflected side. Yes, we call it the real side. That is one way of defining it. But remember, I have defined the object in terms of point of intersection. Point of intersection. What you said is absolutely correct. It should be on the reflected side. That is correct. But the way we have defined incident ray, it should be, the real object should be defined in the same sense. So I am going to say the same thing in a different way. A real object is the object where incident ray converge. No, incident ray actually meet. Do you understand the meaning of actually meet? They will actually intersect. And I will show you a diagram. Don't worry, I'll draw a diagram, I'll show you a diagram. If incident ray actually meet, then the object is real.
Sir?
Then when will the object be virtual?
Sir,
Yes.
can you explain the object from diagram, sir?
Just wait, just write first. Give me time to show my talent, beta. Do not make any assumptions unless until I have told you that I have done with this object. Don't worry. Let me first write. If the incident ray actually meet, it's a real object. Then when will the object be virtual? Tell me. First, let us write. I'll show you the diagram and then we will understand it from the diagram also. If the object is real when the rays actually meet, then when is the object virtual? When they
Extended, sir.
do not meet, or I will say it in a different way, when they do not meet but they appear to meet. And this is what you will write. They do not actually meet but they appear to meet. They do not meet, but it will look like they are meeting. That is the term that we use, that they appear to meet. Real object, they actually meet. Virtual object, they appear to meet. So you can make a column, you can write real object and you can write virtual object. Now, instead of writing it as actually meet, I will write it as incident rays. Incident rays. And first you write it, then I will draw the diagram and show you a diagram. Diverge. Do you understand the meaning of the term diverge? You understand the meaning of the term diverge? Yes or no? They move like this. They diverge. Incident rays diverge. If the object is real, incident rays diverge. Then what will happen when the object is virtual? In case of real object, rays diverge.
Converging.
Yes. Now we will see how it looks like. In this case, they will converge. In this case, they will converge. Diverge or converge. I hope you have written this, all of you. Yes or no? I hope
Completed, sir.
completed. Now let us see it with the help of a diagram, and I will show you that diagram. I hope everyone has written this. Now see this diagram and try to draw it. Now, which one is the real object and which one is the virtual object? I have named two, 1 and 2. Which one is the real object and which one is the virtual one?
First one is the real object, second one virtual object, sir.
That is correct. Now look at what we had defined and also look at what the student has said. He said that if the object is in front of the reflecting side, now this side, there was an old convention which was real world and virtual world. I would just like to elaborate this, real world and virtual world. Now in case of a mirror, this is the real world, which is on the reflecting side, which the student said. And the other side is known as the virtual world. Now you also use this term nowadays, virtual world, the world of social media where you have all sorts of avatars and you pretend to be someone else which you are not there, virtual world. So similarly, we had a convention known as real world and virtual world. In case of a mirror, real world is the reflected world and virtual world is the other side of the world. So the side which is polished. So if something is there in the real side, it is real. If something is on the virtual side, it is virtual. So what he said is correct. When the object is on the real side, it is real. Case number 1, object is real. Case number 2, if you look at here, this is the real side R, this is the virtual side V. Object is on the virtual side and therefore it is virtual. But that is now how we have understood this. Now how we have understood this, let us look at the point that we have understood. The first point that we wrote was incident rays actually meet. Now look at this point. Incident rays are actually meeting at this point. So our point is defined. When the incident rays actually meet, it becomes a real object. When the incident rays do not meet, but they appear to meet, look here, they are not actually meeting because the mirror is coming in between, but they are appearing to meet. That is why Case number 2, object is virtual. We have done it in a different way. When the rays, incident rays diverge, see, you can see this diverging. These are diverging rays, diverging from the point. Diverging. The object is real. When they seem to converge, you can see here, they seem to converge. That is known as virtual object. And again, the definition here is given in the same thing. You may not write this definition because I have already made you understand. Here they have defined it in terms of real world and virtual world. On the incident side is the real world, other side is the virtual world. You may not have to understand this if you have understood the real definition that we have written. And now you have to draw this diagram. This number 1 is a real object where incident rays are diverging. The other one is a virtual object where the rays are converging. Do we all understand this? Yes or no?
Yes, sir.
Great. So you now don't have to write anything. You just have to draw that diagram. And we have already written what is a real object and what is not a real object. We don't call it not a real object. We call it virtual object. Once you are done, let me know, because once we are done with object, which is denoted, as you can see, by the letter O. I hope everyone has noted this down. Object is denoted by the letter O. Image is denoted by the letter I. Capital O and capital I. Capital O is the object. Capital I is the image. Once we have understood what is an object, we will try to understand what is an image. Let me know if you have written this. Don't worry, I'll give you enough time to write this. I'll have to get used to your pace. I'll give you time, don't worry. Object, remember beta, again I keep on telling you this over and over again. If you can understand the meaning of the terms in this chapter, that's it. You don't need anything else. To understand the meaning of terms, question will come only on that meaning, and if you understand them, you are doing exceptionally well in this
Excuse
chapter.
me, sir.
Yes, beta.
Sir, can you please tell us some examples of virtual object?
Beta, the only example that we are going to deal with right now is on your board. That is the only object which is virtual. Now, we will only encounter virtual objects in case of convex mirrors, but that is going to come very forward. After a long time. Whenever a virtual object come, I let you know it's a virtual object. There is no example as such. For example, if you keep your mirror in front of something and the incident rays are actually not meeting, then the object is virtual. Now, how do I give an example for that? Unless and until I actually have a virtual object. In case number 2, if you can see better, the rays are not coming from a real object. The rays are coming from somewhere. The object may be somewhere at infinity. I don't know where the object is, but it seems to be at this point. Now, if we encounter such objects, which we are very hard, they will only come when probably you have multiple reflections, or one reflection, one refraction, then reflection, then only we'll encounter such objects. In most of the cases, in 99.99% of the cases, we'll be encountering real objects, a pen kept like this and a mirror kept like this. This is a real object, not a problem. I cannot keep the pen there and create an image, because then it will not create any image. So we'll hardly encounter any virtual object unless and until it's a case of multiple reflection or refraction, or reflection and refraction, refraction and reflection. You get it better?
Yes, sir. Thank you.
In the most cases, we will be encountering real objects. Virtual are only 1 or 2 cases, and whenever virtual object comes, don't worry, I'm there, I'll tell you. So that was about object. I hope everyone have seen, but Now we come to image. How will I define image? Now we have understood the definition of an object. Now you can tell me what would be the definition of an
Point of intersection of reflected rays.
Great. And that is what I wanted to inculcate. Once you understand something, you can make out the other thing. Point of intersection of incident ray, object. Point of intersection of reflected ray is the image. And that is how you understand one thing and the other thing. Point of intersection of reflected ray. Only reflected or something else also. Remember, right now we are dealing with reflection and therefore we're calling it reflected rays. When we go into refraction, when we go into lenses, concave lens, convex lens, glass slabs, then there will be no reflection. Then we will call it point of intersection of
Refracted rays.
refracted rays. Right now, we are only concerned with reflection. So it is better that we also think about what is going to come ahead. And in bracket, I can write, it can also be refracted rays if it is the case of refraction. It could also be the refracted rays. Well done. So far, so good. Now is the time that we understand that there will be two types of images.
Real and virtual.
Yes, so now we will make a column. On one side, I will write real image. On the other side, I will write, oops, I'm just writing image. I should write virtual. On one side, I will write real image. And the other side, I will write virtual image. And this you already know. What is the first point of differentiation between the two? When do I call an image real?
Actual meeting of reflected rays.
Right. When the reflected rays actually meet. So that is the first point that you will write. Now, once you write it for the real rays, a real image,
The reflected rays actually meet at point.
they actually meet. I will show you. They are meeting. They actually meet. They actually meet. I'll show you with a diagram. Just first write this. In case of real image, reflected rays will actually meet. Then what will happen in terms of virtual image? Will they meet? Or will they not meet? They will not meet, but they will appear to meet. Are we understanding this? Yes or no? Real image, reflected rays will actually meet. You will see them meeting. In case of a virtual object, they will not actually meet. They will appear to meet. Now I can write the same thing in a different way. Here, reflected rays they have to meet. So reflected rays will converge. Reflected rays will converge. In this case, they would be diverging. I'll show you in a diagram, don't worry. Remember what was happening in case of an object. Incident rays, in case of real object, were diverging. Here it is the reverse. Reflected rays are converging. Real image can be obtained on a screen. You must just heard this, yes or no? Since
Yes, sir.
they are real, they can be obtained. Now I can give you an example of a real image. Whatever you see on the big screen, on your computer screen, on your TV screen, on your cinema hall, that is a real image. What you're seeing right now of me, it's a real image. Because you can see it on a, where? You can see it on a screen. I'm a real object and you are seeing a real image of me. Are you getting my point? Yes or no? It can be obtained on a screen if it is a real image. What happens if it is a virtual image? It cannot be obtained on a screen. Number 4. Whenever we see real images, they are always inverted. Now you will see, sir, you are not looking inverted. You are looking as what you are sitting. You are not looking upside down. That's what we call camera technology. Real images are inverted. If the object is like this, the image will come like this, inverted. Object is erect. Image is inverted. You have seen this? You know this? You have read this? Yes or no?
Yes, sir.
What about a virtual image?
Erect.
Yes. So these are the 4 points that right now we must know. The image is erect. I hope everyone has noted. Everyone is noting these 4 points down. Yes or no?
Completed, sir.
Wow, your speed has tremendously increased. I am very glad. Well done. Keep it up. Now remember, as we go ahead, we will be doing a lot of things. I hope everyone has noted down. Can I move onto the diagram and show you how the real image and real object, virtual image and virtual object, and here the diagram comes. Just save time so that we can move faster. See now here. The green ones are the incident rays. Yes or no? Are you getting my point? The green ones are the incident rays. They are coming from somewhere in case of figure number 1. And the blue ones are the reflected ones. Reflected rays are actually meeting at this point. At this point. They are meeting at this point. This is a real image. This gentleman, first, if I call this diagram as diagram number 1, this is the diagram of a real image. What about the object, if I may ask? What type of object is there? Can anyone tell me? Where is the object? What type of object we have? Do we have a
Real object.
Do we have a real object or do we have a virtual object, beta? In this case, the diagram is not complete. Do we have a real object or do we have a virtual object?
Virtual object.
Yes, beta. As you can see, incident rays do not actually meet. But if I trace them back, or in fact trace them forward, they will appear to meet. So in this case, case number 1, my object is virtual. This gentleman is virtual, but my image is real. Someone was asking me, sir, please give me an example of a virtual object. In case of a plane mirror, this is the best example that I can give you. Once we come into spherical mirrors, I'll give you more examples of virtual objects and virtual images, or real objects and real images, or vice versa. So in case number 1, as you can see, object is virtual, but the image is real. Do we understand this? Can I have some reason that we understand this? Great. Now let us move on. And then after that, you can write it. Then I can move on to point number 2, diagram number 2. And who is going to tell me what is happening in diagram number 2? Who is going to tell me what is happening in diagram number 2? I hope everyone can see the diagram. What is happening in diagram number 2? Anyone? What is happening in diagram number 2? Diagram number 2, everyone. Anyone? What is happening there? Diagram number 2. No one knows what is happening in diagram number 2. In this case, as you can see the object here, object is real, incident rays are diverging, actually meeting and diverging. And as you can see, the image, reflected rays, these are the reflected rays, the blue rays. They are not actually meeting, they are going forward. They are not actually meeting, but they appear to meet. They appear to diverge from this point, and therefore this point becomes its image, but in this case it's the virtual image. So plane mirror, we have seen one very good property of a plane mirror, and which we are going to write in the next class, because we are going to start with plane mirror. We have seen a wonderful property of the plane mirror. Plane mirror is the mirror that you use in your homes, and that property is right there in front of your eyes in case number 1 and case number 2. Can you tell me what is the property of the plane mirror that we are seeing right now? Anyone? And that is how you apply the knowledge that you have learned. That is how you apply the concept, and that is what we have to study in physics. A very good property of the plane mirror we have read just now. Can anyone tell me what is that property that we have read just now? What is the property of the plane mirror that we have read just now? Anyone? In first case, object was virtual, image was real. In second case, object was real, image was virtual. We have understood a very important property of the plane mirror. Can anyone tell me what is the property? We are going to write all these properties in the next class. Can you tell me what is the property that we have seen right now? Anyone? No one understands this? For a real object, a plane mirror, for a real object, a plane mirror will always create which image? For a real object,
Virtual image.
yes, for a real object, a plane mirror will create virtual image, and for a virtual object,
Real image.
it will always create a real image. So real object, virtual image, virtual object, real image. That is one property of plane mirror. We'll start with plane mirrors in the next class, and we will see some more properties of this plane mirror. I know you know a lot of these properties. We will see each and every property of the plane mirror in the next class, starting with this, because we have already seen this. For a real object, virtual image is formed. For a virtual object, real image is formed. There are many things that you know about it. I hope you will, before coming to the next class, just go through what we have done in the last class. I'll see you in the next class. And if you have any doubts, you can obviously ask me now. Take care. Bye-bye.